Hello. Good morning. Good morning, everyone. I hope you can hear me. I see that there are a lot of people joining this webinar. So, of course, you are very welcome to this webinar that we will be, the idea for this webinar is to provide you with an introduction of AI in the public sector. Probably a lot of you are aware about the guidelines that were recently published by the department, and we thought that as an activity from the Data to Sustain EDIH, this would be a very interesting topic. We are hosting this webinar on the basis of also previous work and consultations we have made with some of you, and we are here as part of an activity of the Data to Sustain EDIH. You will hear more from Mike Conroy, that is the director of the Data to Sustain EDIH, the European Digital Innovation Hub. And of course, we are also here with Professor Paul Greeny from ATU, that he will be the main person introducing you to this AI for public sector. My name is Jose Manuel Senameterio. I work for ERNACT, and we are also part of the EDIH, the Data to Sustain EDIH consortium. And mainly we are working and targeting public sector organizations like can be your case. So at the end also of this webinar, first we will be consulting you about your main preferences on AI training, because the idea is this is the first of a series of trainings. And actually, this is an introduction of AI in the public sector, but our idea is to prepare further training for yourselves, target yourselves, that will be delivered after the summer, in autumn, winter. For us, it's really important that at the end of this webinar, we will be consulting you which topics are the main ones, or what are your priorities, in a way that Paul and his team can prepare the content for further training, that you will receive information about that. And we hope that is of your interest. So without further ado, we are going to start. Just also to comment you that this webinar is being recorded, and also the presentations and the material will be circulated to you afterwards. Now I will give the floor to Mike Conroy. He's the director of Data to Sustain. That is where this webinar is being organized. So Mike, you can explain more to the audience about what Data to Sustain does. Thank you.
Thank you, Jose Manuel. Good morning, everybody. Thanks for joining. We appreciate it. Delighted to be here today to give a quick update on the European Digital Innovation Hubs, and then move on to the main topic, where Paul will take us through a very relevant and important topic regarding artificial intelligence in the public environment. Briefly, the European Digital Innovation Hubs, I'll give you some brief context at a national level, how they're constructed and how they're working together, and how they support both companies, the type of companies we're working with, and also how we engage with public sector. So the opportunity here is to see if there's opportunities from people on the call or your colleagues to continue that engagement on this topic or other topics. So there are 4 national European Digital Innovation Hubs. They largely sit on top of the innovation and education systems nationally. I represent Data to Sustain, which is largely based in the West and Northwest, but can service clients, public and private, anywhere in the country, but largely focuses on the West and Northwest. I have colleagues in CEDAR, which is the National AI Centre, largely based out of UCD. The entire centre, which is largely based through a consortium in the South and Southwest, and Factory Exchange, which is again a consortium largely based in the Midlands, but serves national customers nationally. The emphasis is that we are working as a network. We meet on a weekly basis. We look at some things that are complementary, and we see how we can support both public and private clients going forward. They are part of a European overall structure that are funded around Europe, with again an encouragement for collaboration. The primary objectives is to support the adoption of technology, largely digital and advanced technology for competitiveness and innovation. The services are provided 100% free effectively, in as much as that is the case for a public sector client. In the case of private companies, it's offset against their de minimis state aid, assuming they are eligible. The objective is to bring together specialization, for example, in artificial intelligence with various application domains. And that's a good example this morning where we talk about the intersection of artificial intelligence and the type of applications in a public sector environment and all that comes from that, both from an innovation and regulation perspective. And we work very closely, as you can see, with the agencies. So on our steering committee, we've got the local enterprise offices, Udros Nagwelta, Westbic, and for example, and other people in this region. And as I said, the objective is not to try to resolve and engage with companies in isolation, but to see how we can bring this network together to help both companies and public sector. Specifically for data to sustain at a very high level, there's 4 pillars of focus, working with companies to develop prototypes and innovations that helps perhaps their client journey and their innovation and investment journey. Like we're doing this morning, provide practical guidelines in education through workshops and other forms of engagement to improve awareness and skills around a range of technologies and application domains. And then we also work with the business agencies to ensure we interlock the investment journey that a company or a client might be on to make sure it's complementary to the technical support. Typically, the slide gives some indications of the type of value that we bring at a services level to companies. We also try to bring together the public and private domain where it makes sense, for example, in healthcare or artificial intelligence adoption, data management, cyber, et cetera. And on the left-hand side, you can see that this consortium is made up of the 9 campuses across Atlantic Technology University. Paul is based in Donegal, but obviously has colleagues around the region. Work closely with the National AI Research Centre in the University of Galway and other groups, and then some of the other agencies and business supports, including the leadership from ERNACT in the European and public space in particular, through Jose Manuel and his team. So this is probably not specific to public sector, but in terms of awareness for people who are on the call, perhaps from regional development authorities or other organizations like my colleagues in the other 4 DDIHs. We've been very busy over the last 18 months. We've personally worked with about 270 companies, executing 204 projects across 125 unique organizations. And we go through a particular process. I'll talk in relation to that. And one of the important roles is to bring together different specializations that are applicable to run ecosystem and training and awareness events that then potentially leads to either other types of engagements or investments or individual projects on a one-to-one basis. I'll just flash this up. It'll be in the slides when they come around. We typically work with companies over anything from a 1 to a 6-month period. And these are some of the sort of application domains and some of the combination of technology and applications that come together. There is a strong, increasingly strong artificial intelligence focus, whether that's around sort of language or visuals or more traditional machine learning, data management, or cyber-related activities. But you get a feeling for that. Jose Manuel will talk a little bit at the end regarding some projects we're doing across the public sector, ranging from environmental, tourism, just other public data mechanisms. So he'll give you some examples there. But what I would say is it's not just about data to sustain. We have also colleagues at CEDAR and elsewhere working with individual county councils and elsewhere. So if you've a wish to follow up either around skills and training or workshops or individual projects, please reach out to us and we'll try and navigate at a one-stop shop level to colleagues in other EDIHs to see how they can help. The steps are fairly simple. Once you register, we go through a kind of mandatory digital maturity assessment, which is reasonably high level. That results in a report, but more importantly, in a narrowing in an area of potential service delivery, which might be as simple as a workshop or consultancy or an innovation. And we typically have a very lightweight service agreement to do that. The funds exists within the DAH to make the decisions between the client and the service, and then we go and execute that. So I will leave that's the background, and that's some of the boring stuff in terms of how we work, but we'll come back to it at the end. And if there's people who want to reach out to me on the chat, please drop something in there. So we'll move on now to the main event, and I'll pass it back to Paul, who, and I think we're in for an interesting overview and session. And just to emphasize, if you have questions as we go, please pop them in the Q&A, and we'll pick them up as we go. We may interrupt Paul if we think it's necessary, but otherwise we'll try and address those at the end. Thank you very much, and over to Paul.
Thanks, Mike. So I'll just share my slides. It should be visible now, is it? Okay, so welcome everybody. It's great to have you here. Great to see such an interest in the topic. So what I'm going to be talking about today is largely driven by the recently published guidelines for the responsible use of AI in the public service, published by the Government of Ireland. So a lot of what I'm going to cover is based on the headings in that document, but also starting off with some more basic content on what is AI, what is generative AI, what is a large language model. So these are terms that I guess everybody has heard at this stage. So hopefully at the end of this session, you'll leave with a high level idea of what each of those terms means. Okay, so I'm not going to go into any large technical detail on them. I'm just going to focus on definitions and examples. So I'll go through those, then I'll look at some applications of AI and large language models in the public sector. Then taken from the EU AI Act, we're going to look at some of the risks posed by AI systems. So there are some systems that are unacceptably high risk under the EU AI Act and can't be considered. There are some that are high risk, and there are a list of contingencies and things that have to be done if you want to develop technology in that within that list. So we'll go through those as well. And we'll finish up then with a look at the AI system lifecycle and responsible AI principles that guide our development of AI systems. So first of all, what is AI? So usually when you look for definitions or introductory material on AI, you'll see some sort of a diagram like this on the right here. So AI in the largest bubble, and then sitting within that, machine learning, deep learning, generative AI, and large language models. So we're going to be working our way down through this. So starting off at the top, artificial intelligence. So there are loads of different definitions of AI out there. They're not particularly clear, some of them. So I'm going to explain them through some simple examples. So some of the standard definitions are AI is the study of agents who receive signals from the environment and perform some actions, or AI is concerned with understanding and building intelligent entities. Okay, so that's very abstract. So some concrete examples then that we typically use to illustrate those definitions. So one of the simplest ones, which sits in this machine learning category here. So I know the number of bedrooms in a house and the floor area of the house. What will the sale price of the house be? Okay, so we can use those two pieces of information, the number of bedrooms and the area of the house, to build a model that will predict the sale price. So that's a standard machine learning problem. And none of this is new, by the way. These applications have been around for years now. Another application from the computer vision end of things. So this sits in the deep learning circle now. So I have a camera streaming video content from the front of my car, so streaming images, and I want to know when the brakes should be applied. Okay, so I need, in that case, a system that's going to detect if there's another vehicle in the frame or a pedestrian in the frame, and in that case I want to send a signal to apply the brakes. And a third one, I have a set of insurance claim applications or any type of applications, and I want to identify which ones are fraudulent and which ones are genuine claims. And again, that's a machine learning application within AI. So in all of these cases, we have a model or a system that's receiving a signal and performing some action. So if we take the first one, the signal is what is the number of bedrooms and the area of the house, and the action is to predict the sale price of the house. So we have an input-output process there. So if we take that idea then and try and extend it to some applications in the public sector, we could come up with some questions like this, or some applications like this. So I have data on library usage patterns and local demographics, maybe from Central Statistics Office or somewhere else like that. And I want to use that data or those inputs to answer the question, which locations need additional services or extended opening hours. So again, that's a machine learning problem. I have images from road inspection cameras, and I want to know from those images, I want to determine which potholes or road damage require immediate attention versus routine maintenance. So again, that's another computer vision problem, and it sits in this deep learning sphere. So deep learning generally refers to areas where we're using images or large volumes of text or videos. And a third example, I know the location or size and type of a proposed new development, and I want to know what is the expected impact on local traffic patterns. So again, I have some input information, the location and the size and the type of the development, and I want to predict the output, which is the change in the traffic pattern or the total traffic volume that will be caused by this new development. So those are all, I've said here, traditional AI applications, and by traditional I mean they're not generative AI. Okay, so generative AI is probably the latest buzzword in AI, but these applications or applications like this of AI have been around for many years now. So they're well-established algorithms and models for doing this sort of thing. So that's AI in general. So the next thing we want to answer is what is generative AI? So it's in the name really. Generative AI is AI that can generate some output. And typically by output in this case, we mean image, text, or video information. And the one most people are probably familiar with now is text generation that large language models are used for. So generative AI models will create new content by learning patterns from existing data. Okay, and I put new in quotes there because it's not really new. It's reproducing patterns that it's seen in its training data. Okay, so it's trained on massive amounts of existing data, and it generates content that looks like the training data. So if we're going to do that, we're going to need massive amounts of data to learn this. So large language models are typically trained on huge amounts of data gathered from the internet and books and other sources like that. And this has become a big business for a lot of corporations. So there are many companies now that provide access to trained models. So models that have been trained on these massive amounts of data, and then the companies have made those models available for public use. So ChatGPT, Gemini, Claude are all language models that are publicly available now. And on the image side, for image generation, DALL-E and Midjourney are available for those applications as well. So I'm not going to focus at all really on the image generation side, because a lot of the applications I think in the public sector are on the large language model text generation side. So the third of those three questions that I want to answer in terms of introductory material is, what is a large language model? So we've said already it's a model that generates text. It's a generative AI model that produces text. And it learns how to do this. So it's trained to do this by learning patterns from huge data sets of existing text. The idea being that it will reproduce or learn those patterns and then generate text that looks like that data that it came from. So if the data that it's trained on is sensible and makes sense, then the output of the model should hopefully make sense as well. So in mathematical terms, and this is the only theory really I have in all of this presentation, the model outputs a probability distribution over all of the words in those data sets. So in that huge data set of existing text that the model is trained on, we might have maybe 50 to 100,000 unique words. So when we're generating new text with that model, the output is a probability distribution over those 50 to 100,000 words. And the output that we select is just the word that has the highest probability. So what the model is doing is given an input text, a piece of text as its input, it's predicting what should the next word in that sequence of words be. And then the one after that and the one after that and so on. So it's doing next word prediction. So as an example here on the right, so our input is, it's nice today, the weather is, and we want our model to provide a response to that, so to complete that sentence. So the output we might get, the probability distribution we might get as output of our large language model might have the words sunny, hot, rainy, cold, and nice, for example. And each of those words is going to have a probability associated with it. So what the large language model is responsible for is deciding what these probability values should be. And at the end, then we just take the word that has the highest probability and output that as the next word prediction. So based on that, sunny here has the largest probability. So the completion of this, if we ask our model to complete the sentence, is the weather is sunny. So if we're asking it a more general question requiring a more complex response, so more than one word in essence, what will happen here is it will take sunny as the next token, and then it will continue if we need more words to complete a response, it will continue taking whatever the next highest probability is in the following distribution. Okay, so it'll reconfigure and continue generating words until the question is answered. So that's on the technical side of things. So hopefully it gives you a very high level idea of how this type of model works. We're not going to go into any of the technical details on how the model is coded or anything like that. Lots of services or companies now have services where you can just take one of these models out of the box and apply it to whatever particular problem you're interested in. So you can take a pre-trained model and generate a chatbot out of the box by providing it with the data that you want to it to use to answer particular questions. So why is generative AI, or why are large language models so popular then, or why is there so much talk about them? Well, they're a huge leap forward compared with what was available before. So they can generate context-aware, personalized answers that will match the tone and style and the intent of the user. They can learn from data and learn from feedback to improve their performance and adapt to changing needs. So if I have a model that I'm using for a particular task, I ask it a question maybe and it doesn't give me a satisfactory response, then I can tell the model what the response should be if it's incorrect, and the model will then use that to improve its performance, so that the next time somebody asks it that question, it's going to have that feedback that you provided, it's going to update its knowledge based on that, and it's going to hopefully give a better answer the next time. Okay, so there's an opportunity for this continuous type of feedback where the model is constantly learning from feedback from users where it's gone wrong or where it might benefit from further knowledge. And that means it can adapt to changing needs. So if something changes in an organization, if its information goes out of date, then you can provide it with new information in the form of further text input or providing it with a document that contains updated information, and it will update, again, its model based on that. And another key point that comes up in a lot of the applications we'll look at is that it can integrate real-time retrieval to augment its training data. So when ChatGPT first came out, it always came with the warning that it's only been trained with data up to something like December 2021, and it couldn't access any other sources of updated knowledge. But now most large language model services available online have this real-time retrieval integrated into them, so they can access the internet, access up-to-date sources in real time while they're retrieving the answer to your question. So you'll see that in a lot of models now, that they actually go and retrieve information from the internet immediately once you ask the question, so that it gives a better quality answer. So then it's using both the patterns that it's learned from the training data as well as the real-time retrieved information to answer the question. So that's a very powerful feature of large language models. So it's also useful or important to keep in mind that there are a lot of limitations to these models as well. So even though we call it artificial intelligence, it's not really intelligent in any way, and certainly not in the way humans are intelligent. So all of the large language models that are available on the market are just reproducing previously seen patterns. So we have a huge corpus of text data that the model has been trained on. All the model is doing is learning what is the correct way to place those words one word after the other. So next token prediction all the time. That's what it's doing. So in the training data, the sequence of words makes sense. So if the model follows the patterns in that training data, then the sequence of words that it's going to output are going to make sense as well. So that's all that's going on. There's no real intelligence. It's not capable of any thought or anything like that. Most people, if you've used any of these models, you've seen that they can hallucinate. So even in if you search for something on Google now and you get an AI summary at the top of the page, a lot of the time you'll see there's incorrect information in that because it's forced to give you an answer, but the answer isn't always correct. Okay, so that idea of hallucination is always present. So you always need to fact check what your model is doing, fact check the output, and that also leans into the idea of requiring human expertise. Okay, so we can't have untrained humans using AI systems if they're not capable of judging whether the output is correct or not. So we're always going to need that human expertise sitting alongside the model. So it's not a case of replacing the human expertise with the model. You need human validation and verification in that loop as well. So there is a risk in organizations using this in an unsupervised manner. Okay, so in missing human expertise to check the outputs. Okay, if we don't have anybody who knows what the output should be, then we have no way of validating if the system is working correctly or not. And if we use a model in some sort of automation system, so if we're using it, say, to sort emails and send them to the correct person in an organization, if we trust that automation with insufficient human supervision, then that is a point where things can go wrong. Okay, if there isn't a human in the background that is capable of intervening and responsible for intervening if something goes wrong, then we're going to run into problems there. So it's important to keep those limitations in mind when using any of these types of technologies. So for some examples then, I'm going to start with Notebook LM, which some of you may have seen already. So I'm guessing most people on the call have already interacted with some sort of AI large language model like ChatGPT or Claude or Gemini or one of those. So Notebook LM is another similar service from Google. The difference with this service is that it can accept a document as an upload. So it allows you to create a session where you're essentially conversing with the document that you've uploaded. So I took as an example the Galway County Council CCTV policy, which is publicly available on their website, and I've uploaded it to Notebook LM. So when you upload a document, the interface will provide you with the summary, and then it will provide you with the standard input box where you can input any query that you want to ask of or about the document. And it'll also suggest some questions as well. So I put in a very simple question in here. Does the policy allow for CCTV use in prosecution? So it'll answer the question, but the important thing or the interesting thing about it is it will answer the question using evidence, so citing particular points in the document where it found the relevant information that it used to answer your question. So if you hover over any of the citations at the end of the bullet points in the output, it will point you to the specific paragraph in the document that it used to generate this bullet point summary. Okay, so that really reduces the potential for hallucination because the model has to provide the evidence for the points that it's making. Okay, it's not just generating a summary and saying this is what the document says. It's actually pointing you to the information in the document where it got that evidence from. Now, that's not a particularly useful application in this case because that policy is only 13 pages long and we could easily review it manually or search for a term in it. But if you think about a larger application of this, if you have multiple documents that you need to synthesize or review all in one go, or grab information from multiple documents to inform a single new document or policy, or if you have documents that run to hundreds or even thousands of pages long, then this is a much more efficient way of interacting with those documents. So if you're in the multiple document case, you can just upload multiple documents and query them the same way as you'd query the single document. Or if you're in the hundreds of pages, then you have a very quick, efficient way of searching for information in that document. And this covers as well cases where if you're doing a find and search in the document, you may not necessarily find the term you're looking for. So for example, just taking one of the words on the screen, securing and secure. If you search for secure there, it's not going to find this occurrence of securing. Whereas if you search for a term involving secure or security in an AI model, it's going to use those different forms of the word, take that into account, and it's able to handle that because of the patterns that it's learned from the large data sets that it's been trained on. So in some cases, this can be a much more efficient way of interacting and searching through documents or looking for particular information. So what I've just done is used a free publicly available generative AI tool to analyze a publicly available document. So that is permitted under the public sector guidelines, but they do caution against the use of free tools in general. And the reason for that is that free models in general will use user-supplied information to train their model. So uploading something that's publicly available is not really a risk, but uploading anything sensitive or confidential is a very big risk, really. So because the information that we upload or provide or type into a publicly available model is then being used by the company to train their model or to further refine their model, that means that information that we supply as the user could be exposed to other users later. So anything we input into a publicly available AI service is potentially or can potentially be exposed later on to another user. So that's a very important point to keep in mind. And the advice from the National Cybersecurity Centre on this is that it's imperative that data that your organization doesn't want in the public domain is never entered into a public Gen AI model. So any sort of classified information, personal data, commercially sensitive data, private government business, you need to keep that away from any publicly available AI tool because it will be used to train and further refine the model, and there is a risk that that data is exposed later on. So free tools like this, fine for public information, but anything sensitive, really have to stay away from those type of tools. So on to some examples then of where generative AI is being used in the public sector already. So the Department of Agriculture, Food and Marine is one of the government departments in Ireland that is implementing a lot of generative AI solutions at the moment. So they're using it for implementing chatbots to interact with customers, and they're also using it for detecting errors in document submissions for grant applications. So their use case is if a client uploads sensitive information that shouldn't have been included as part of their submission, they have a model that will detect that will screen the application, flag that there's potentially sensitive information here that shouldn't be visible to staff in the department. It will flag that for attention by an authorized user who's authorized to review it, and then it can be anonymized before it goes for the actual assessment of the grant application. And we'll look at another example from that department of a chatbot in a second. Another application is in query routing. So routing incoming emails to an appropriate inbox. So the revenue commissioners are using this type of system to take incoming queries to a general email inbox and routing those to the correct internal department within the revenue commissioners based on the content of the email. So they have a system that's been trained on previously received emails and the correct person that those emails should have been sent to, and then the AI system learns from those patterns. The input is the email, the output is the inbox or the person it should be sent to. It learns from those patterns where future emails should be sent to. And of course, there's always a backup there of if it's not sure, it should flag it for attention by a human user, and they decide where the query should go to. There are also applications in internal communications management or internal information management. So the National Transport Authority are using large language models to collate answers to parliamentary questions. So they get questions in from public representatives, and they have to research the answer to those in their policies, in their own internal documents. So previously that would have been done manually, and now they have a system where LLMs are used to assist them in that. Okay, and that has more than halved their response time, about 54%, I think. And again, it's important to emphasize there that there is always human oversight in this type of application. So it's not a case of just generating a response with the AI system and sending that off to the person who's asked the question. That's really a recipe for disaster. So there's always a human review there before the response gets sent back. So while the model is used to collate the answer, there's always a human at the end who reviews the output generated and checks if it makes sense and if everything it's saying or claiming is correct. So this is the chatbot interface that I mentioned that the Department of Agriculture is using. So this is available on their grant application system. So when a customer signs in, this virtual assistant pops up and it offers them several choices if they want to ask questions about any of the grant schemes that the department offers. So it's integrated within their existing online grant system. They've projected that it will be used by about 14,000 farmers who are applying for grant schemes, so about 10 to 15% of their total user base. And it's worked pretty well for them, and they're planning to expand it to a wider range of use cases within their own department. So I've included some of the technical details there if anyone's interested in the technical side of it, but I'm not going to go through them. But they're there if you want to look at them. Another example of where a system like this could be used, but on the internal side of an organization, so not a customer-facing application, is in creating an AI-driven knowledge database. So a knowledge database is a repository of information or documents coupled with an AI system that is capable of answering questions about those documents. So any medium or large size organization will have a large collection of policies, so say HR, finance, travel, recruitment, data protection, will have a set of policies like that. So we could hook that up to an AI system that will allow a user to interact with those policies. So we could have, say, a chatbot like on the previous slide, but for internal use within an organization where an employee can ask questions about the organization's policy on a specific topic. So that enables rapid query answering. So questions like, does our policy on X allow for particular action Y? And again, it improves that idea of having to manually locate a document and then manually search through it. Okay, so the natural language processing approach taken using an AI model will allow for better retrieval of information. So it's a much quicker and smarter way of searching and retrieving information. And again, you'll have some sort of system where it points to the specific source within the document, and you can go and open that and read it then. But you've already located where the information is. So systems like that can be created very easily. So Microsoft Azure and other platforms have out-of-the-box systems that you can use to create a chatbot or a knowledge database like this. And you can add knowledge to it by pointing it to web addresses, by uploading documents, and by connecting it to internal systems like Microsoft SharePoint if the organization uses that, or whatever internal document repository as an alternative. And one further example then is in policy research. So a lot of organizations are using AI models for this type of application as well. So using AI to summarize and synthesize information from policies and from other documents. So this can be applied then to preparing new policies, documents like development plans and so on. And the inputs can be any other type of document, so publicly available policies from other regions, government documents, other relevant internal documents can all be supplied as the input, and then we create some relevant output from that. And that type of system can also be used to screen documents against policies. So, for example, we have environmental or road safety or planning policies in a local authority, and we want to screen a planning application against those policies. So does a particular planning application satisfy our environmental or road safety policy? So the system is capable of doing that comparison and providing us with a detailed evidence-based answer to that type of question. So this is being used at the moment in the Office of Public Works. So they have a pilot system that uses generative AI to summarize policy documents. And again, the positive outcome there is that it speeds up urgent decisions or information requirements. It could be used for ministerial briefings and for press releases. So it allows for interactive conversations with documents, the same as we saw earlier on with the CCTV policy and Notebook LM, and the same as the internal knowledge base. So we're using an AI system to interact with a document or a set of documents. And they've also integrated the Oireachtas Debates Archive as an extra knowledge database or an extra set of documents that can be used to improve the quality of their results. So those are some examples of where generative AI is currently being used in some public sector organizations. There are other examples, but those are kind of the headline applications at the moment. So hopefully that gives you some idea of where this type of technology might be useful in some of your own organizations. So the next thing I want to talk about is the potential risks and how they can be mitigated. So potential risks of using generative AI or using AI in general. So with any AI system, there's always a risk of bias or discrimination. So every system is trained based on data that's been gathered by humans or is based on human behavior. So there's always bias in data gathered by humans or bias in humans' own decisions. So that's going to be present in the data, and that means we're always going to be training a model on data that is potentially biased. So in a service that's customer facing, there is the possibility for unintended discrimination. So for example, if we have a system that's assessing eligibility for housing assistance, that might consider an applicant's residential address, their connection to the area, their current accommodation, and so on. If we train that on historical data, okay, so historical or past housing assistance applications, then if there was bias in how those decisions were made, then that bias is going to be present in how our new system makes those decisions. So for example, newly recognized disabilities that weren't recognized in the historical data, then there may be bias against people who disclose those types of disabilities. If somebody comes from an area that historically has had a lower approval rate, then the model is going to learn that applicants from those areas have historically had lower approval rates, and more than likely the model is going to have a lower approval rate for applications from those areas as well. So of course that can be taken into account, but you have to keep it in mind in order to do that. So you always have to keep in mind the potential for unintended bias in any type of AI system that you're creating. There are also risks around transparency and explainability. So it's not acceptable to tell a customer that this decision has been made by AI without being able to explain to them how it has made that decision. Okay, so you can't just say that it's a decision made by an algorithm and leave it at that. So these type of black box algorithms can make decisions difficult to understand and explain. So there is an important point around explainability there. So the organization has to understand how the model works and be able to use that to justify it to the user. Okay. And there's also the risk of dehumanization of services. So you don't want the customer's only route to interact with the organization to be through a chatbot. So there has to be some human backup there if they're not getting what they need from the chatbot, or if they're unable to interact with the chatbot. So you have to keep in mind that there is a risk there of a lack of flexibility in your system that risks a loss of the human touch in public services. Okay, so there should always be some sort of human backup there if the system fails or is unavailable. So the EU AI Act defines different levels of risk and the appropriate action that should be taken when you're in those different levels. Okay, so there's a section at the top of this diagram of prohibited AI systems, so where the risk is considered to be unacceptable and these applications can't be used. And then proceeding down from there, there are high, limited, and minimal or low risk systems. So I'm not going to go through all of these. They're listed in the summary document that I've included the link to in the slides, and they're also in the public sector guidelines as well. So I'll just briefly list some of the systems that are considered unacceptable risk, and then some of the high risk ones as well, just so that you're aware that this this framework is in place and that you should consider what is the risk of your system before you consider implementing it. So under the EU AI Act, any type of social scoring where you're scoring a person based on their characteristics or their personal history is completely forbidden. Any type of risk assessment for the potential for criminal offence, any type of facial recognition databases, so scraping the internet or CCTV images to create or expand facial recognition databases, prohibited. Any type of emotion recognition in a workplace or education scenario is also prohibited under the AI Act. Now, most of those aren't applications that would come up in most organizations, but it's just worth remembering that they are there. Any type of biometric categorization to deduce protected characteristics, and any type of biometric identification, remote biometric identification for law enforcement in public spaces is also prohibited. So I've included the link there to further information on those unacceptable risk systems and the risk system in general. And a few of the high risk ones there. So as you go down, you'll see more applications fall in under these categories that an organization might consider implementing. So the high risk ones are permitted, but there are stringent mitigation requirements to address the risk posed by them. So under the high risk heading, any type of component in critical infrastructure. So if you have an AI system that is performing some action in a public transport system, or any type of transportation system, and if that component fails, if it has the potential to put the life or health of citizens at risk, then that's considered a high risk system. Any type of tools for employment or management of workers. So the one you'll typically see discussed in the media and in public discourse is CV sorting or screening software for recruitment, where an organization uses AI-powered software to screen or sort applications for jobs. Those are considered high-risk systems. And in particular, in that case, again, if you don't have the human oversight, so if you have a system that's potentially automating your recruitment by sorting and discarding applications based on the information they've provided, then potentially there are applications that never get seen by a human. So that is a very high risk system in that case. Because if it's going wrong, then we don't know unless we're monitoring it. And any type of use in migration or asylum or border control or administration of justice or democratic processes, those are all high risk, considered high risk systems as well. So if your potential application falls into that high risk category, there are stringent regulations on those systems. So there has to be some type of risk mitigation. So you have to identify what the risks are and how you're going to mitigate against them. High quality data sets have to be generated and used to train the models. All of the activity has to be logged, both in terms of developing and training the model, and also all of the inputs and outputs once the model is actually deployed. That has to be logged. You have to provide detailed documentation and clear user information. There has to be a high level of human oversight, and there has to be a high level of robustness and accuracy and cybersecurity. So robustness and accuracy, the model has to behave as expected, and you have to monitor it to ensure that it continues to behave as expected and that the outputs are correct and continue to be correct. So in the public service guidelines that I've been talking about since the start, really, it defines a life cycle for developing an AI system like this, like we've been discussing. So starting off with the design, the data, and the models that you might use. Then once the system is defined and trained, then there's a verification and validation step. Then we go to deployment, where it's made available to users. Once it's deployed, we have to make sure it continues to operate in the way that we expect. So there's continuous monitoring that has to happen there. And then eventually we'll reach a stage where we need to retire or decommission or refresh the model. So the public sector guidelines have 7 principles for responsible AI, and then each of the stages in the AI system lifecycle is informed by those, or should be informed by those 7 principles. So from design through to deployment and operation, you have to keep these 7 principles in mind for any system that you're developing. So the 7 principles are human agency and oversight. We always have to have a human involved in the system. Technical robustness and safety. So the model should work as expected and it should be safe for users to interact with. Privacy and data governance. We have to use data in the correct way. Transparency. We have to be able to explain to our users why we're using this model and how it works. Diversity, non-discrimination, and fairness. We have to make sure that the system doesn't have unintentional biases in there and that's not discriminating against any particular group of people. Societal and environmental well-being. We always have to keep in mind whether or not using this system has a net benefit to society, or are the drawbacks more significant than the benefits that it's providing. And the last one, accountability. So there always has to be somebody in the organization who's accountable for any AI system that's being used. Okay, so there's always a human at the back of all of these systems. So within each of the steps in the life cycle, then those 7 principles always have to be kept in mind. So the implications of that are, if we're at the planning and designing phase, then we have to define where human oversight and control is going to be integrated into the system. So that has to be defined from the very beginning. How is human oversight going to be guaranteed? We have to ensure that the system that we're developing is going to follow the organization's data security policies and the requirements for data security under the EU AI Act. A fallback plan has to be established at the planning phase as well. So what's going to happen if the system malfunctions or if it becomes unavailable? So what is our fallback plan? Is there sufficient human resources available for the case where the model isn't, or the system is not currently available? And we have to ensure privacy at all points. So if the situation or the application warrants it, we have to conduct a data protection impact assessment. We have to follow the relevant security protocols. Data has to be appropriately anonymized if necessary. So any type of personal information or sensitive information needs to be anonymized. We should also carry out an evaluation on how to make the system as accessible as possible. So in particular to vulnerable groups, for example. So universal design principles should be followed. And there should also be an impact assessment or future scenario planning. So who's responsible if something deviates from the intended output or behavior? So if the model is not providing the expected outputs, who is responsible in the organization for that? Who can put in place a plan to fix or address that problem? So that's in the design phase, and then moving on to the actual model creation and training phase. So again, you always have to ensure the human involvement. So consider human involvement in assessing the outputs even during the training and tuning of the model. So when the model is actually being developed, we have to ensure that the model can be explained to the level that's designed in, or defined in the design phase. Continuously test for bias. So check the outputs during the training to make sure that bias is not present. And consider the environmental impacts. So what this really means, or the kind of headline in this case, is that there are lots of different models available. You shouldn't be using a model that's larger than what you require for your application, because that's going to have a detrimental effect on the environment. So every AI model uses extensive resources in terms of electricity and water. So you should consider whether the model you're using is too complex or too large for the application that you're interested in. So whether a better choice can be made there. And of course, that will have a cost implication for the organization as well. In the verification and validation stage, again, you should be testing for the inclusion of human involvement and control over the decision-making process. You should consider the potential unintended applications and potential abuse of the system. So how are you going to handle it if a user or a malicious user accesses the system? What's the plan for that scenario? For testing, you should be testing it in a small-scale pilot environment, so you don't deploy it and then use that as the testing phase. And you should engage with the IT security team, really at all stages, but in particular for validating your model to ensure that all of the processes are being correctly followed. In the deployment stage then, you should be providing users with appropriate information to make informed choices about whether or not they want to use an AI system, or to make informed choices about using the system. If there is any potential for the system producing legal effects on the user, you have to provide an additional process. So you need to ensure that the user has the right not to be subjected to decisions based solely on automated processing. So again, there has to be the human alternative available to them in that case. And you have to provide appropriate training for anybody who's going to be using the system. So that's the internal case, or user guides to end users if it's going to be a customer-facing application. You should monitor the performance of the system to ensure that it continues to be robust. You should ensure that the fallback plan that was defined in the design phase can be activated if the system fails or isn't performing as intended. You should ensure that the system is deployed securely, so it's only available to the required users and not to anybody else. And it should be made clear, so you need to make available an explanation of the degree to which the system is influencing decision-making within the organization. So if you're using an AI system to make decisions within an organization, you should clarify and make available an explanation of what degree of influence this system is having on the decision-making process. You should always make it clear as well to humans that they're interacting with an AI system, or if they're interacting with outputs that have been developed using AI, that always has to be made clear. You should monitor the decision-making process of the system during deployment to ensure that it's making decisions in a fair manner, and ensure that the accountability framework that you've defined in the design phase as well is followed. So ensure that AI decisions can be traced back to a human that's responsible for them, ultimately. So those are some of the implications of the responsible AI principles for each stage in the design and development and operation of an AI system. So you should also, just to finish up on that, gather and review feedback from users, so standard with any type of system really, and also evaluate whether or not users understand that they're interacting with an AI system. Because if they don't understand that, then you need to make that clear. So you need to adapt your communications to make it clear that they're interacting with an AI system. And you should continue to test post-deployment. So in the operation and monitoring phase, test the system to ensure that it continues to produce fair and non-discriminatory results. So to finish up then, the guidelines document provides a very good decision framework to be used when you're deciding whether or not AI is an appropriate, or AI systems are appropriate for the particular problem that you want to solve. So it runs to a few pages in the document, so it's worth going and having a look at it in more detail if you're considering that. But just to summarize some of the main points from that, the type of question that you should be asking yourself, or the team should be asking if they're considering this, is AI the best solution to the problem that you have? What type of AI solution is the best fit? Can you use a free of charge solution, or will a licensed product be required? So as we said, in most cases, that's going to be, you're going to need a paid service. So using any of the publicly available models is not generally a suitable solution to any organization. Is the cost involved justified? So you're not just going to have a cost in purchasing some software. You're going to need infrastructure to run the model. You're going to need data. You're going to need somebody to actually develop or implement it, and you're going to need to pay for the ongoing operational costs in terms of running the model and in terms of monitoring and overseeing its deployment. And are the resources available in the organization to do that? So we just listed a whole range of potential costs to the organization. So you need to consider the ongoing operation and maintenance, as well as the design and development and deployment of your system. So that is everything I wanted to say today, I think. So I'll hand you back to Jose Manuel.
Thank you, Paul. Thank you very much for this really good presentation. I hope the attendees have found it really interesting, and you have now a better idea. As we commented, this was supposed to be an introductory webinar for AI and potential application in the public sector, but as part of our plans, as in the skills part of the Data to Sustain EDIH, we plan to run a series of training late in the year, around autumn, winter. And we would like to hear from you about the main topics or the main priorities you would like us to focus on. So we have created a Slido poll that my colleague is going to share the screen here. So we appreciate that if you can either scan that QR code if you can use your mobile, or if not, we are going to put a link in the chat if you want to use your laptop or your desktop, and please enter in the poll where we are going to make just a couple of questions. Maisa, can you also put the link in the chat if anybody wants to use the... While you are putting the link, I see in the questions and answers or in the chat that there are no questions, but there is a really good suggestion from David McLaughlin about a massive online course on AI. So yeah, thank you, David, also for that suggestion. So the attendees can also check there. Okay. Okay. First question. My colleague already put the question on the screen. So the first question is very simple: is that if you believe that AI could help in your daily work, and probably after Paul's presentation, you can also have a better idea about if that can be useful or not on the daily tasks that you have. So yeah, we see that more than 80% of you think that AI can help you. Not sure, maybe needing more information. What is interesting to see is that none of you believe that is not useful. So I think this is also a really good input for us to see that what we are trying also to deliver you is useful for your daily work. So maybe we give just 10 seconds more for people to reply to this question. And then the next question that you will see on the screen is about that maybe can take you a little bit more of time, but it's an important one. So my side, you can put the other question on the screen. Is about, you see there, okay. The idea is that we want to provide this further training. So we would like you to rank all those options according to your priorities. The way that this answer works is that you rank from 1 to 4 based on your preferred options. Okay, so there are 4 topics where AI can be applied. The first one is process automation. That is about increasing your efficiency and reducing manual tasks and repetitive tasks. Second field of intervention where AI can be applied is service delivery. So can be by setting up chatbots or translation services supported by AI. Also oversight and accountability. So to analyze large data sets and maybe detecting unusual patterns. And then the final one is about policy making. So using AI to provide insightful data views to make decisions. So we are going to give you maybe 30 seconds more to read this and to provide us with this feedback. We wanted to seize the opportunity that you were online today, but we will also send you a similar survey or questions with all the material that is going to be distributed to you after this webinar, okay? Including the recording, access to the recording, and also the presentations. But we will include also a small survey that you can also share with others that weren't able to attend today to gather that information. That is useful information for us to better shape the training that we plan to deliver to you. Yeah, we are leaving the Slido longer, taking Tanya's suggestion. No problem. We can leave it for 20 seconds more. While you are still replying, basically this was our webinar today. I'm just going to, when we are finishing this slide, this Slido poll, I'm just going to share a slide with you, also reminding you the type of services or projects that you can also avail from contacting us in Data to Sustain. Some examples that are under development and delivery with some public sector organizations. So this would be all from our side. So maybe we close here the poll. Thank you very much. And then very quickly, I'm going to share my screen with you. just to spend 1 minute to comment you some other services that maybe public sector organizations could access in data to sustain. So there are some possibilities there. For example, thanks to some of our partners in the consortium, mainly ATU and University of Galway, we are running some projects that uses smart furniture and building automation. They use Internet of Things technologies that can be applied. In this case, they are being applied in natural parks to monitor different conditions in the parks, including noise, also pollution. So these are type of projects that we have a lot of expertise in the consortium and could be useful to be applied in the services that public sector organizations like your ones have to deliver. A lot of possibilities also in type of immersing services using virtual reality and augmented reality with a lot of potential to be applied in fields like tourism, culture, and it's also being used in or applied into health. And finally, also as part of these training services that, for example, this AI that we are launching today, there are also other possibilities that maybe could be relevant to be delivered through the libraries or community centers, like maker space, maker labs training for digital fabrication. So it was just to give you just a flavor of some examples of services that you could check with us if you are interested. So if that is the case, you also have there the contact details. So get in touch to us and we can see if with you if this the possibilities to deliver this type of services and also others. So please feel free to reach us. This is all from my side, at least. Finally, I just want to thank all of you for attending this webinar, and in particular to Paul for this nice presentation, and also Mike, of course, for supporting us and all the work you are doing in data to sustain. Thank you, and we finish here. Okay, bye-bye, everybody.
Thanks, everyone.
Thank you.